Hey everyone, welcome back to Class Bites, your place for quick and easy lessons that make learning simple and fun. Hope that you liked our previous clip for ocean currents and how the sea controls regional climates. In today's topic, we will see the major factors that influence global climate patterns. Grab a few minutes and let's learn something new together.
The Earth's climate is shaped by a complex combination of natural and human-related factors that work together to control temperature, rainfall, wind, and other weather conditions over long periods of time. These factors interact with one another, sometimes strengthening or weakening their effects. Understanding these influences helps explain why some regions are warm and wet, while others are cold and dry, and why the global climate can change over centuries. The major factors that influence global climate patterns include the sun's energy, the Earth's tilt and rotation, the movement of air and oceans, the distribution of land and water, the composition of the atmosphere, and the impact of living organisms and human activities. Each of these plays an important role in shaping the climate we experience today. The sun is the main source of energy that drives the Earth's climate system. Without sunlight, the planet would be cold and lifeless. The sun's rays warm the Earth's surface, oceans, and atmosphere, creating temperature differences that cause wind, rainfall, and other weather patterns over long periods of time. However, the Earth does not receive sunlight evenly. Areas near the equator receive more direct sunlight throughout the year, making them warmer. In contrast, areas near the poles receive sunlight at a lower angle, spreading the energy over a larger area and resulting in cooler temperatures. This uneven heating is the foundation of global climate zones, from tropical regions near the equator to polar regions near the poles. The tilt of the Earth's axis is another key factor that influences global climate patterns. The planet is slightly tilted rather than standing upright as it moves around the sun. Because of this tilt, different parts of the Earth receive varying amounts of sunlight at different times of the year, creating the seasons. When one hemisphere tilts toward the sun, it experiences warmer temperatures and longer days, while the other hemisphere tilts away and experiences cooler temperatures and shorter days. This cycle repeats every year, shaping predictable seasonal patterns that affect farming, animal behavior, and natural ecosystems. The rotation of the Earth also influences climate. As the planet spins, it causes air and ocean currents to curve, a phenomenon known as the Coriolis effect. This effect helps create global wind patterns, such as the trade winds and westerlies, which distribute heat and moisture across the planet. Finally, the shape of the Earth's orbit around the sun changes very slowly over thousands of years. These small shifts can influence how much sunlight different parts of the Earth receive, leading to long-term climate variations such as ice ages or warmer interglacial periods. The atmosphere is a thin layer of gases surrounding the Earth, and it plays a crucial role in regulating the planet's temperature. It acts like a blanket, trapping some of the sun's heat and keeping the surface warm enough to support life. Certain gases in the atmosphere, such as carbon dioxide, methane, and water vapor, are known as greenhouse gases. They absorb heat and release it slowly, a process called the greenhouse effect. Without this natural effect, the Earth would be too cold for most living things. However, when too many greenhouse gases accumulate in the atmosphere, more heat is trapped, leading to an overall warming trend known as global warming. This imbalance affects rainfall, sea levels, and weather patterns around the world. The oceans cover most of the Earth's surface and store large amounts of heat from the sun. Ocean water does not stay still. It moves in a system of currents that flow around the globe. These currents act like massive conveyor belts, carrying warm water from the equator toward the poles and bringing cold water back toward the equator. For example, warm ocean currents help keep nearby coastal regions mild, even during colder months, while cold currents can make nearby coastal areas cooler and drier. This exchange of heat between the ocean and atmosphere strongly influences the climate of continents and islands. Oceans also play a major role in regulating weather events. When surface waters warm or cool significantly, they can alter wind and rainfall patterns on a global scale, leading to events such as prolonged droughts or heavy storms. The way land and water are distributed across the Earth affects how heat is absorbed and released. Land heats up and cools down more quickly than water. As a result, regions in the middle of continents often experience more extreme temperature changes between day and night and between seasons. In contrast, coastal areas, surrounded by large bodies of water, tend to have milder and more stable climates. The shape of continents also affect wind and ocean currents. Mountain ranges can block moist air, causing one side to receive heavy rainfall while the other remains dry, a pattern known as the rain shadow effect. Similarly, the size and location of continents influence monsoon patterns, deserts, and storm tracks. The movement of air in the atmosphere, called global circulation, is another vital factor that shapes climate. When warm air rises near the equator, it cools as it moves toward the poles and sinks back toward the surface. This circulation creates large wind belts that move heat and moisture around the planet. These winds influence where rain falls and where dry regions form. For instance, areas where air rises often experience clouds and rain, while areas where air sinks tend to be dry and desert-like. The direction and strength of winds can also change due to differences in temperature between land and sea, helping to create seasonal wind systems such as monsoons. Elevation, or height above sea level, has a direct effect on climate. As altitude increases, temperature generally decreases. This is why mountain peaks are often covered with snow, even in regions near the equator. Air also becomes thinner and holds less moisture at higher altitudes, which can lead to cooler and drier conditions. The shape of the land, known as topography, influences local climates. Mountains, valleys, and plateaus can block or redirect airflow, creating microclimates, small areas with different conditions from their surroundings. For example, valleys may trap cool air at night, while south-facing slopes in the northern hemisphere receive more sunlight and warmth. Plants and other living organisms influence the climate by affecting how energy and moisture move between the land and atmosphere. Forests, for example, absorb carbon dioxide and release water vapor through a process called transpiration, which helps regulate temperature and humidity. Areas covered by dense vegetation tend to be cooler and more humid, while areas with little vegetation, such as deserts, are usually hotter and drier. Deforestation or large-scale land use changes can disrupt this balance by reducing moisture in the air and increasing heat absorption at the surface. In modern times, human activities have become one of the most significant influences on global climate patterns. The burning of fossil fuels, deforestation, industrial processes, and large-scale agriculture release greenhouse gases into the atmosphere. These gases trap extra heat, causing global temperatures to rise gradually. This warming affects the movement of air and water, altering rainfall patterns, melting ice in polar regions, and changing the frequency and intensity of extreme weather events such as heat waves, droughts, and storms. In summary, global climate patterns are shaped by the interaction of many natural and human-driven factors. The sun provides the energy that fuels the system, while the Earth's tilt and rotation determine how that energy is distributed. The atmosphere, oceans, winds, and landforms all work together to move heat and moisture around the planet. Vegetation helps maintain balance, while human activities can disrupt it. Each factor plays a unique role, but none operates alone. Together, they form a dynamic system that constantly evolves, influencing every living thing on Earth. Understanding these factors helps scientists predict changes, plan for the future, and protect the delicate balance that makes life possible on our planet.
That's it for today's Bite of Knowledge. If you enjoyed this video, let us know what you want to learn next down in the comments. And hey, hit that like button and subscribe to Class Bites so you can keep learning and improving a little every day.